Tesla has finally made a huge jump in humanoid robotics, and for those of us who've watched robots grow from Honda's Asimo to Boston Dynamics Atlas, this feels like a totally new chapter. In Tesla's latest teaser, the engineering team shows off Gen 3's trial runs. The Tesla bot Gen 3 isn't just walking more smoothly, it's learning quicker, grabbing objects with care, and working alongside humans in real-world places without needing step-by-step code. This is a big step in independence. That strange knee bend move you might have noticed. It's not a mistake, it's a planned choice for balance. If you've doubted Tesla's robot until now, you're not alone, but what the engineers just shared could shift your view. This is a massive deal. One Tesla engineer put it like this: Optimus will be the biggest product ever, by far, nothing will come close. They think it'll be 10 times larger than the next biggest product ever. That's the kind of excitement coming from the Gen 3 testing lab, and once you see what's next, you'll get why. What makes Tesla bot Gen 3 seem like it's catching up to humans? Remember those funny memes comparing Optimus to a clumsy uncle? Jokes like, walks like it's tipsy, fresh from leg day, or, grandpa learning to step again, flooded social media for a while. They stuck around until recently, when Milan Kovic, head of the Optimus project, shared a clip on X with a short note: "Our latest walk, straight knees, smoother heel-to-toe steps, and arm swing, just relaxing, fully trained in simulation with reinforcement learning." Many thought the bent knee walk was bad design, and it's fair to think that. Tesla's only been building humanoid robots for just over 2 years, so doubts make sense. But there's a deeper story. The bent knees hide clever insights most don't see. At first, it looks slow, awkward, and not practical for real tasks. It was slower. Last year, Optimus moved at about 1 meter per second on flat ground, but that wasn't its max. Tesla aims for 2.2 meters per second when it's ready for sale, and now it's hitting 1.8 meters per second steadily. For most humanoid robots today, that's like a sprint. Tesla's now focusing on improving Optimus movement and hand skills. A recent factory video shows Gen 3 stepping with knees fully straight, ankles cushioning heel impact, and arms swinging for balance. The stiff, robotic shuffles are gone. This isn't just for show, it's a big upgrade for stability, helping Optimus stay steady on factory floors, in homes, or on slightly rough ground. Making it walk like this is tough. The more human-like a robot moves, the trickier the engineering gets. For straight-leg walking, the knee and ankle joints can't absorb impact like bent ones do. Tesla had to make the robot's actuators, its muscles, super precise to deliver smooth, stable force to the ground, or it'd wobble or fall. They did this by lightening the actuators, sharpening control algorithms, and tweaking joint damping to cut every millisecond from each step. Optimus needs strong but light actuators so they don't mess up its balance. Without a tight control system, its moves would be jerky, stiff, or even make it tip over. It's a machine, it can't perfectly copy a human body, and we shouldn't judge a robot that's just over 2 years old too harshly. Let robots be robots. Truth is, we don't need a robot to do thousands of tasks. Even if it could handle over 1,000 functions, we wouldn't use them all for one job. A robot's here to help, not replace us. Humans, with our quick reflexes and smooth muscle control, are great at balance. For Tesla bot, all that's mimicked with joints, sensors, and cables. So, the fact that Optimus moves as naturally as it does is a huge win. If legs are for moving, hands are for doing everything. Tesla's engineers have put nearly half their effort into perfecting Gen 3's hands and forearms. To make a humanoid robot do what humans can, it's a high bar. The new arm has 22 degrees of freedom, up from 11. Forget the claw-like grippers of earlier models. Gen 3 has 5 fully movable fingers, each a different length for better grip. Tesla learned that varied finger lengths improve dexterity, like why we have a pinky. They moved the heavier actuators to the forearm, making the palm slimmer and more human-like. The hand is almost half the engineering in Optimus from a mechanical view. In tests, Gen 3 catches small balls, threads cables through tight spaces, and folds clothes with a finesse that could impress your neatest friend. The human hand, with 27 degrees of freedom, is one of nature's most complex designs, letting us grip, squeeze, pull, write, draw, or play music. Copying that in a robot is a massive challenge. It's not just about looks but working accurately in real settings. A 22-degree of freedom hand and forearm is now in production, learning to walk and catch balls. In a short time, Optimus has gone from an idea to the most advanced humanoid robot on Earth. By doubling the degrees of freedom, Tesla's moved past simple tasks, letting the robot handle complex ones. If Elon Musk's vision comes true, Optimus could become a daily life staple, like C-3PO or R2-D2 in Star Wars. We might see robots like Optimus doing chores, caring for the elderly, or performing precise tasks in medicine or research, replacing or supporting humans in repetitive, risky, or delicate work. Optimus is becoming one of the world's most exciting robots. If Tesla markets it well, how we live and work could change entirely. Imagine robots handling dull, tough tasks, from assembly lines to housework, elder care, or dangerous jobs. This wouldn't just cut labor costs but boost productivity and improve life quality. How is Tesla Bot Gen 3 smarter in real settings? The big jump from Gen 2 to Gen 3 is Tesla's advanced autonomy tech. The same neural network that guides their cars on highways powers Optimus. Tesla leads in real-world AI, and what they learn from cars applies to the robot. They also use their skills in electric motors, batteries, power electronics, and structural design. Plus, they're great at manufacturing. Over years, Tesla's shown they're not just good at building electric cars but leading in real-world AI. They've built an AI system for self-driving cars, which Musk calls a robot on wheels. Now, they've given it legs to make Optimus. By using EV parts like batteries, actuators, FSD software, and gearboxes, Tesla's built a robot cheaper than most rivals. But mass-producing millions of Optimus units from the start isn't easy. Even with those parts, fitting them into a human-sized frame needs extreme efficiency, or you get a bulky or awkward robot.